Hi everyone, I'm going to be going over the rational functions quiz review. The topics we're going to be covering are the transformations of rational functions, how to graph based on the transformations, identifying properties of the graph, listing the order of transformations from an equation, transforming a point and writing an equation from the transformations, and then finally writing an equation from a graph. So the first thing we're going to do is graph two rational functions. We have to plot two asymptotes and 1 point on each branch, or in other words, each curve on the function. So looking at 3 over x minus 1 plus 2, I'm going to just start by identifying all the transformations. So I see that there's a minus 1 next to the x. So that tells me I have a horizontal transformation. And then I see the 3 in the numerator, which tells me I'm going to have a vertical dilation. And I have the plus 2 at the end, which is a vertical shift. So I'm going to take the time to write these in order. In order to graph, you don't have to put them in the correct order, but I think it's good practice. So you have to start with either all the horizontal or all of the vertical transformations. I think it's easiest to start with the horizontal first, especially because in this case, there's only one horizontal transformation. So when I see the minus 1 next to the x, that's telling me I have a horizontal shift. And what you see in the equation is always the opposite of the direction you're going to go in. So if I see a minus 1 with the x, that means I'm actually going to be shifting to the right one. So my first transformation is shift right 1. Now that that's my only horizontal transformation, I can go on to the vertical ones. So I have a dilation and a shift. With vertical transformations, I need to make sure I go in the order of PEMDAS. Dilations are like multiplying, and then shifts are like adding or subtracting. So multiplying comes first in PEMDAS. So my dilation, my vertical dilation of 3 is going to come next. And then lastly, I will have my shift up 2. So vertical transformations are what you see. So if you see a plus 2, it's shifting up 2. It's not the opposite like with the horizontal. So again, that's only with horizontal transformations that you end up with the opposite of what you see. So those are 3 transformations. So to start, I'm always going to start by graphing my asymptotes. So the asymptotes are affected by the shifts. So I'm going to start just by looking at the shifts. So my first shift is shift right 1. I have to think about which asymptote is going to be affected by a shift to the right. So I've got my vertical and my horizontal asymptote that originally on my original graph are at 0 and 0. So both asymptotes are originally on the x and y axes. So if I shift right 1, that's going to change my vertical asymptote. So it's originally at 0. I shift right 1, my new asymptote is going to be at 1. So this is going to be the asymptote. I'm going to draw that one more time. So I shifted right 1. So that's my new vertical asymptote. Okay, I should probably just do it with the pen because this is just too thick. Sorry. So my vertical asymptote again comes from shifting right by 1. Once I have that, I'm done with the shift. I don't really need to worry about it at all. Because as you'll see when we plot the points, we're just going to have like a new center of our graph. So that will take care of the shift. Now I need to graph my horizontal asymptote, which is going to be moved by the vertical shift. So if my original asymptote is at 0 and I have a shift up 2, my new asymptote is going to be at 2. So that took care of my shift up too. Okay, so again, now that I've done my asymptotes, it's important that we treat this center right here as the new middle of our graph. So I'm not going to look at 0, 0 as the origin anymore. I'm going to treat this intersection of the asymptotes as my new origin. As long as I do that, I don't have to worry about the shifts anymore. I just have to think about where my 2 points are going to go. So this is where we think back to our original graph, which is 1 over x, in case you forgot. That's our original graph. And on that graph, in order to plot the 2 branches, we go to the right one and up 1, and to the left one and down 1. But we have a dilation on ours, so ours isn't going to look quite like that. So we're going to think about our original points, 1, 1, and -1, -1 on our original function. Now, if I do a vertical dilation of 3 on the point, that tells me I'm going to multiply my y value, because it's vertical, by 3. So my new points will be 1, 3, and -1, -1, -3. So that tells me the direction I need to go in from my new origin and how many units to go. So the 1, 3 tells me to start at my new origin, go right 1 and up 3. That gives me a point. The other one tells me to go left 1, down 3, and that gives me another point. So again, it's not like, I understand that obviously we didn't actually put a point at the actual 0.13 and the actual point -1, -3. We're just thinking about what the original function looks like, dealing with any dilations and reflections, and it just tells us how many to go to the right and to the left and up and down in order to plot these 2 points. So it's just telling us what direction to go in and how many units to go. And then from there, you only need 1 point on each. These are called the branches. Whoop, don't know what happened there. These are called the branches of the rational function, and you just need to sketch them. So your graph should not have like any straight lines on it. It should look like it should definitely go through those 2 points, and then it should be getting very close to the asymptotes. So don't have your graphs on people's graphs look kind of like they're leveling out here. That's not correct. You need to make sure it's leveling out very close to the asymptotes. Okay. All right, and that dealt with our vertical dilation. So I have all my transformations. Now I just need to identify my properties. So my vertical asymptote, that's always x equals. Okay, just think of it as it's always the opposite. Vertical asymptote is at x equals 1. My horizontal asymptote is at y equals 2. My domain, I can look to the left of my graph and see that I have an arrow pointing to the left. So I am always starting at -infinity. My domain, it's tempting to say -infinity to infinity, but I have a break in my domain at the vertical asymptote, which is at 1. So my domain stops at 1 and then starts again right after 1, and it goes all the way to the right. So your domain should always look something like that, because it's going all the way left and all the way right, but it has a break in the middle. The range is similar. It goes all down forever. So -infinity. Remember, range is bottom to top. Domain is left to right. And then the range, it has a break at 2. And then it starts up again right after 2. And it goes up forever. So your domain and range should always look something like that. You should have 2 intervals. And it should just be showing that there's a break at each of the asymptotes. Right, and behaviors. So first one is saying as x goes to -infinity. That's telling me to the left. What is my y value approaching on the left side? So if I look at the left side of my graph, I see that the x is going left forever, but vertically it's not going up forever, it's not going down forever. It's getting very, very close to the pink asymptote, okay, which is at 2. So my y value is approaching 2. And this should always be on the left and the right side of your graph. you're always going to be approaching whatever your horizontal asymptote is. So it's always going to match what your horizontal asymptote was. And then to the right side, as you can see, same thing. Go look to the right, is getting very, very close to, y is getting very close to 2. The next one is saying, so that one's the right side. The next one says, as x approaches 1 from the left, this minus sign here, I'll highlight it real quick. This minus sign is telling you from the left side of 1. The plus side is saying from the right side of 1. So this is the left and this is the right. It's not a coincidence that it's talking about our vertical asymptote. It should always match that. That's kind of a way to check yourself on the quiz. If I ask you about a number that is not your asymptote, then you might have made a mistake. So as x goes to 1 from the left, if I look at my graph on the left side of the green asymptote, my graph is going down. So my y is going to negative infinity. And then on the right side of the green line, my graph is going up. So my y is going to positive infinity. All right, I tried to go as slow as possible through that one, so I might go a little quicker through this one. So let's look at all the transformations. I see that I have x plus 4, so that's a horizontal shift. I see I have a dilation of 2. Now, let's not say a dilation of negative 2 because the negative is actually a separate transformation. It's telling us about a reflection. And then lastly, I have my minus 4, my vertical shift. So I'm going to list these. So I first have I'm going to start with my horizontal. The only horizontal transformation I have is the plus 4, which is telling me the opposite of what I think. It's not a shift right, it's a shift left 4. So that's my first one. Now I'm going to move on to the vertical. The reason the reflection is a vertical transformation is because it's telling us to change the sign of the y values. So that's actually means if we're changing y, it's a vertical transformation. So I've got a reflection, a dilation, and a shift. So we talked last time about how the dilation has to go before the shift. That's true, but now we've also got the reflection. The reflection and the dilation can actually go together. So because think of it as like negative 2, you see it as one number. That means they can go together, so you can put them in any order. You can either say dilation, then reflection, or reflection, then dilation. I'm going to say dilation, vertical, dilation of 2. And then I'm going to say my reflection. Remember, I'm changing the y value, which means I'm reflecting over x. Whenever you see the negative on top, just think that's reflect over x. It means my y value gets switched. If you switch your y value at any point, it's going to flip over the x-axis. And then lastly, I have my shift down 4. So you've got 4 total transformations here. Let's see if I can get this to move. All right, so I'm going to now go to my asymptotes. So I'll start with the vertical asymptote. The vertical asymptote gets moved by the horizontal shift, which is at the top, the shift left 4. So if I shift left 4, my original asymptote's at 0, my new one's going to be at negative 4. It's really hard to draw the vertical ones in a straight line. So my shift left 4, that's taken care of. Again, I don't have to think about it again. Once I do my shifts with my asymptotes, don't have to worry about the shifts anymore. Now I have my shift down 4. So if my original horizontal asymptote's at 0, my new one's going to be at negative 4. So now, again, I'm going to treat this spot right here as my new origin. I'm not going to look over at 0, 0. I'm going to treat this like my new origin. So I've got my shift left and my shift down are dealt with. I don't have to think about them anymore. Now I have my dilation and my reflection. This is where the dilation and the reflection just impact where we put our points. So again, in my normal 1 over x, if I just had shifts and I had 1 over x, I'd be putting points right 1 up 1 from the origin and left 1 down 1 from the origin. but we've got a dilation and a reflection. So we have to take care of those when we look at our points. So if 1, 1 is my first point, my dilation of 2 tells me to multiply the y value by 2. My reflection over x tells me to change the sign of the y value. So I'm just going to do it all in one go. I know that when I multiply my y value by 2, I'm going to get 2. And then I also need to change the sign, so I'm going to end up with 1, -2. So we did two things. Dilated it by 2 and changed the sign, because when I reflect over x, I change the sign of my y value. And then I have my -1, -1 point. First, if I do my dilation, I get -1, -2, but then I have to change the sign of y so that I reflect. So it's going to be -1, +2. So now I just use those to graph my new points. So my first point, 1, -2, tells me to go right 1, down 2. And my second point is -1, 2, so that tells me to go left 1, up 2. So again, you can tell if you reflected, because look at my graph on the right that wasn't, or sorry, on the left that wasn't reflected. I've got I've got a branch in the upper right quadrant and the lower left quadrant. And you can see in this graph that they're in the opposite quadrants, and that should always be the case. It should be in the opposite quadrants if you reflected it. So I did my dilation and my reflection. So now I'm good. All right, so my vertical asymptote, that's x equals -4. My horizontal asymptote is y equals -4. My domain, it should look similar to my last one. So it's going all the way to the left, and then it's stopping at -4 where my asymptote is. Starts again at -4 and goes all the way to infinity. My range, it goes down forever, and then it stops at the pink asymptote, which is -4 also. And then it starts again at -4 and goes to infinity. My end behaviors, I've got as x goes to -infinity, which is telling me the left. So on the left side of my graph, my y value, well, my graph is, as it goes to the left, is getting very, very, very close to the pink line, which is at -4. Same thing on the right, it's getting very, very close to -4. Now, as x goes to -4 from the left, remember the minus sign tells you from the left, the plus sign tells you from the right. And again, not a coincidence, this is the same as the green vertical asymptote. That's -4. So as x goes to -4 from the left side, I see my graph is going up. So my y is going to positive infinity. And on the right side, I see my graph is going down. So that's negative infinity. And you can see that this is the opposite. The negative infinity and infinity are switched from what we had in the last one because of that reflection. All right. All right, good. So we're done the front. So number 3 asks us to describe the transformations needed to map 1 over x onto the g of x, which is the transform function. Make sure you list the transformations in the correct order. So this is, we kind of already practiced this, but this is just, we have to make sure we're doing it in the correct order. Whereas with the graphing, you could have listed it differently. Now, I see 2 transformations. I see the -3 and I see the +4. So the -3 with the x is definitely a horizontal transformation because it's with the x, and then the +4 on the side is a vertical shift. So since I have one horizontal shift and one vertical shift, it doesn't matter what order I put them in. I'm going to put horizontal first just to be consistent. The -3 is telling me to shift right 3. And then +4 is telling me to shift up 4. I think that one should be pretty doable because the order really doesn't matter. You could have put it in either order. The only thing you could make a mistake on would be the saying shift left instead of shift right. So just be careful with that. -5 over x -2. So here I see I see the negative, which I know is its own transformation. I see the 5, which is a vertical dilation. And then I see the -2, which is a vertical shift. There's nothing with X, so that means I don't have any horizontal transformation. So all 3 of my transformations are vertical. Again, if you say dilation by -5, that's not correct. You have to list the reflection and the dilation as 2 different transformations. So I've got a reflection, a dilation, and a shift, all vertical. So I just need to make sure I put them in the correct order. Vertical goes in the order of PEMDAS. So multiplication comes before subtraction. The -5 part, that's a multiplication. It's multiplying the 1 over x. So that's going to have to go first. I can say the dilation or the reflection first. It doesn't matter because they're on this. They're both considered like multiplication. So I'm going to say vertical dilation of 5, and make sure you say vertical. I mean, we're mostly just doing vertical dilations, or I'd suggest you always write things as vertical dilations, but just make sure you're super specific. And we'll say reflect over x, not y. If you see a negative on top, it's telling you to reflect over x. And then shift down. Those are your transformations. Right, next one, 1 over 3x plus 1. So first of all, I see the 3 with the x. So you might want to call that a horizontal transformation, but I think we should just look at this as a vertical transformation. A lot of people want to call this a horizontal dilation, and you can, but if you say that, you have to do the opposite. So it wouldn't be, a lot of people I think will make the mistake of saying horizontal dilation of 3, which is wrong. Because with horizontal, you always do the opposite. So it would really be a dilation of 1/3. So technically, if you say horizontal dilation of 1/3, that would be fine. But I think it's a lot easier to look at this as a vertical dilation of 1/3. Because if I look at this, I've got this 1 over 3 with my 1 over x. It's like 1/3 multiplying 1 over x. Whenever I have a number multiplying 1 over x, I can just say that's a vertical dilation. And then I have the plus 1. So if I'm choosing to look at these both as vertical, which I think is the easiest thing, I'm going to have to say my dilation and then my shift. So with vertical, again, it's just easier because you say what you see. So if you see 1/3 with the x, then you say vertical dilation of 1/3. If you think about horizontal, you have to do a little more thinking of what's the opposite. So here I see the 1/3, so that means I have a vertical dilation of 1/3. Remember, the dilation comes before the shift because of PEMDAS. 1/3, and then I have my shift up 1. Great. And last one, I have 6 over -x plus 9. So I'm going to go through and pick out what I see. I see the 6 on top is going to be a vertical dilation. I see the negative in front of the x is going to be a reflection, and then the plus 9 with the x is going to be a horizontal shift. So I'm going to still stick with saying the horizontal ones first, but this time I have 2 horizontal transformations. I've got the shift with the 9, and then the negative in front of the x is telling me to reflect. So this is the opposite of what happens when you have a negative on top. Think about if you change the sign of your x value to be the opposite, you're going to be reflecting over y. So I have a reflect over y and then a shift. The plus 9 tells me I'm going to shift left 9. So again, x is a little hard because you got to think about the opposite. You also have to think about the opposite order. So with vertical transformations, we go in the order of PEMDAS. So if this was a vertical, we'd do the reflection and then the shift. But it's not, it's horizontal. With horizontal, you do things in the reverse order. So we're going to have to do the shift and then the reflection, because the shift is like adding, and then the reflection is like multiplying. And with horizontal, we do reverse PEMDAS, or some people say SADMEP, I think, is reverse PEMDAS. So the adding and subtracting, which is the shifting, comes before the reflecting, which is like multiplying. So I'm going to shift left 9. So again, everything's opposite. It's plus 9, which means shift left, and the shift comes before the reflection or dilation. So the negative in front of the x tells me to reflect over y. And then lastly, since I just did both of my horizontals, I have one vertical transformation to list, which is the 6 on top. So that tells me vertical dilation of 6. Okay. We're done with that. All right, go over to number 4. It says the following transformations were performed on the graph of f of x to create the function g of x. Use the table to determine the coordinates on g of x after all 3 transformations are complete. The graph is horizontally, so I'm going to just go one by one. The first transformation is the graph is horizontally translated 3 units to the left. So I see the horizontally. That means I'm going to change my x. 3 units to the left. That's telling me to subtract 3 from my x values. So a lot of people are like, I thought it was the opposite. It's only the opposite when you're looking at an equation. If I'm actually moving a point, think about like if you move a point to the left, you have to subtract 3 to get it to go left. So if my original point is 1, 1, and I subtract 3, then I'll end up with, I'm only subtracting 3 from x, so I end up with -2, 1. And then for -1, -1, if I subtract 3 from the x, I get -4, -1. The next one says the graph is vertically dilated by a factor of 2. So vertically tells me y. Dilated by a factor of 2 tells me to multiply by 2. So I'm going to take my y values and multiply by 2. I need to take the points I just created from transformation 1 and use them for transformation 2. So don't go back to your originals. So I'm going to multiply the y value by 2. So I keep the -2, and then 1 times 2 gives me 2. I keep the -4, and then -1 times 2 gives me -2. Last one, the graph is vertically translated up 1 unit. So vertically tells me y, up 1 unit tells me +1. So I'm going to take my y values and add 1. So the x stays -2. Add 1 to the 2 gives me 3. Keep the -4. Add 1 to -2 gives me -1. Now it says write a correct equation for g of x based on the transformations. So I'm going to think about, okay, well, my original equation is 1 over x. Now I've got a horizontal translation 3 units to the left. In my points, to get my points, I had to subtract 3, which means in my equation, I'm going to do the opposite. I'm going to add 3. And then I have a vertical dilation of 2, which tells me that my numerator, that's rough. My numerator needs to switch from 1 to be now 2. That comes from the vertical dilation. I still have my fraction bar. And then vertically translated up 1 unit tells me I need to add 1 to the y, which means I'm going to have the adding 1 to the right of my equation, not in the numerator or the denominator. Great. Last one. Oh, actually for this, let's do a quick check here. So if you want to check your work, which I highly recommend, take one of the x values. So I'll use -2, plug it in. So from your last transformation, take one of the x values, plug it into this equation you made, and see if you get out your y value. If you did everything right, you should. So if I plug in -2, I have 2 over -2 plus 3, and then plus 1. So my denominator, -2 plus 3, will give me 1. 2 divided by 1 gives me 2, plus 1 gives me 3, which is what I got up here. So that means I did everything right. All right, last one, write the equation of the graph shown below. So I'm going to start by just focusing in on my asymptotes. So I see this vertical dotted line is at -1. I know my original graph has that line at 0. So that means that I'm just going to write down all the transformations I see. So that means I have a shift left 1. Right? I just think it helps to write down all the transformations. So I see that it shifted left 1 because of the asymptote. The horizontal asymptote is down at -4. So that means I had to have shifted down 4. I'm not listing these in the correct order. I'm just listing them in the order that I notice. Now, the next thing I see is where the 2 points are. So normally my point would be right 1, up 1 from my new origin, but it's right 1, up 3. So there's no reflection because I'm in the correct initial quadrants. But if it's going right 1, up 3, that means I had to have a vertical dilation of 3. Again, that's like if I'm thinking about it, my original point that I would have is 1, 1. But the point I'm seeing is 1, 3. Right 1, up 3. So to get from 1, 1 to 1, 3, I would have to multiply the y value by 3, which is a vertical dilation of 3. So those are the only, and there's no reflection because, like I said, right 1, up 1 just became right 1, up 3. If it was a reflection, it'd be going down instead of up there. So to write my equation, my initial equation is always 1 over x. I've got the shift left 1, which tells me I need to add 1 in the denominator. My shift down 4, which would be minus 4 on the outside, and then the dilation of 3, well, that has to be changing my numerator to be 3 instead of 1. So 3 over x plus 1 minus 4. All right, that's everything. Good luck, and yeah, let me know if you have any other questions.